Hello again. This time, we will be using software STAAD ProConnect to check if our stiffness matrix method for 2D jointed structures are correct. Okay, so verification tayo ngayon. And we'll also show you na ang ginagamit ni software ay stiffness matrix din. So, new tayo. New. Let's say demo. Demo frame. From stiffness matrix sample. Okay. Then create. Minimize ko lang ito. Tapos, yung ating first node is, gagayahin natin ito, no? Node 1 would be 0, 0. Node 2, 0, 6. Node 3, 4, 0. Node 4, 4 and 3. Node 5, 4 and 6. Node 6, 8 and 0. Node 7, 8 and 3. Tapos, dito sa beam, dito na tayo sa connectivity. Element 1, that is start node is 1. Or that is node A, ano? Oops, sorry. So, this is 1 and then 2. Tapos, this is 2 and 5. And then 3, 4 and 5. And then 4, 3 and 4, 5, 6 and 7. And then number 6, 4 and 7. Okay, so view, i-front ko lang siya. Next is doon na tayo sa supports. Ang support natin ay pinned, fix. Ito. So, this is pinned and then fix. Dito tayo ngayon sa STAAD. Click nyo lang itong supports. And then create. Tapos, click mo si pinned and then add. Ngayon, click natin yan. I will use cursor to assign. Then, click ko dito. Tapos, create again. This time, fixed. Okay, add. Click ko ito. Then, use cursor to assign. Click ko dyan. Then, that's it. After that, dito na tayo ngayon sa properties muna, no? Ito, properties. Dito sa properties, meron tayong since pare-parehas ang kanilang elasticity, 210, tapos ang kanilang moment of inertia tsaka area ang magkaiba. So, pag samasamahin natin ngayon yung unahin natin si 8400. So, click properties dyan. And then, click define. Punta tayo ngayon sa general, dito. And then, piliin nyo lang si steel. Tapos, ang area natin would be 0.0084. And then, enter. Take note na, 8,400 raised to the negative 6, that is equal to 0.0084 meters squared. Okay, so hindi ko na i-explain yan, ano? Negative raised to the 10 to the negative 6. Okay, and then AX, that is the cross-sectional area, no? And then AY, AZ, gawin mo lang 0 yan. Dito tayo ngayon sa IY tsaka IZ. Ang value niyan ay 0.003 24. Ito. Okay? And dito kay spreadsheet natin, sa sample, this is 204 moment of inertia. Saan nga ba yun? Yeah, to. The moment of inertia is 240 by 10 to the negative 6. Okay, so i-move natin yung decimal places by 6 decimal places. So, tatlong 0 yan, ano? So, yan ang lalagay natin dito sa IY. 0.123, tatlong 0, and then 24. Ganon din dito sa IZ. 0.123, and then 24. Tapos, ito, gawin mo lang 0 lahat yan, and then you click add. Then, close. Next, mag-define ulit tayo. This time, ang pipiliin natin ay yung 9400 by 10 to the negative 6 meter squared, which happens to be 1, 2, 3, 4 members. Okay? So, markahan natin yan ng green. And, it so happened na pare-parehas din ang kanilang moment of inertia. So, meron na tayong dalawang properties. So, balik tayo dito, define, and then general. Ang AX natin would be 0.0094. Okay. Dito, 9400 by 10 to the negative 6 meter square. Ngayon, i-move natin yung decimal place 6 places to the left. Okay, so 1, 2, 3, 4, magiging 0.0094. Yan yun. Okay? And then, ang IY niya, tsaka IZ, that would be, i-move natin yung decimal place niya ng 6 places to the left. Or that is 0.00027. Okay? Ganon din sa kanyang IZ, 0.00027. Then make sure that the material is still and then you click add. Next, property. Click ulit natin si define. General, again. Then, palitan mo na kagad yan ng steel. Ang area X natin would be etong 85 by 10 to the negative 6. That is 5100, ano? And that is 0.0051. And then, ang kanyang moment of inertia, this time magiging apat na zeros na. 0.123485. Ganon din dito sa IZ. 0.1234, apat na zeros, and then 85. Okay, and then you click add. Then close. Now, let's double click each of them. Okay, 0.0024. Then 0.00027. Ayan. 5 decimal places. Okay lang yan. Okay, looks good. Next, i-assign natin itong una. Take note that the first is 0.0084. Ito yon. And that is only assigned to element 1. And nasan si element 1? Ito yon. Okay? So, we will click this. And you click assign. Use cursor to assign. Then, click mo yan. Next, let us click 2. And saan ngayon yung element, saan naka-assign si property number 2? Okay. And that property is 94. Nasaan si 94? Ito siya. Assigned siya sa elements 2, 3, 5, and 6. Okay? Elements 2, 3, 5, and 6. Ngayon, paano mo malalaman kung anong element yan? So, punta tayo dito sa View, Label Settings, then Beam Numbers, and then okay. Yan. So, you click that, assign, use cursor to assign, ito, then assign. Click mo si elements 2, click mo yan, 3, and then 5, then 6. And finally, if you will click 1, ito siya, correct? And then click element reference 2. Ayan siya. Finally, ito, i-assign natin ngayon siya dito lang sa baba. Okay? Then I will press escape. Kung gusto mong makita sa 3D view, let's go to view. And then, palakihin lang natin ito. '3D rendering. Ayan. Yan siya. Next, maglo-loads na tayo. So, dito tayo ngayon sa loading. You click this and then sa load cases details, you click add. And then, number 1, ang title niya, let's say dead. Okay? And then add, then close. Tapos i-click mo yan and then you click add. Ang una nating ilalagay would be the 40, no? So, member load tayo. Tapos uniform force, that is 40. Take note, let's say global X. Ito ang click natin. Global X means X direction, okay? And positive siya kasi to the right. Okay? Now, add. Tapos, close natin. Ayan siya. And then, click mo yan. And then, use cursor to assign. And then, click assign. And then, click mo ito. Next, click natin si dead. Click ulit natin si add. Member load pa rin tayo. And then, uniform force, this time, yung 50. So, dito sa W1, negative 50, in the sense na it is acting downwards. So, global Y tayo, GY. Okay? Now, you click add and then close. So, click ulit natin yan. And then, use cursor to assign. Click mo dito. Finally, dito na tayo sa concentrated load. So, i-click mo itong dead and then add again. Member load pa rin tayo. But this time use concentrated force with a value of negative 200. So you will notice na ang unit nyo dito ay kilonewton na. Tapos global Y pa rin since acting vertically downwards or towards the center of the earth. Global, okay? Tapos negative value. And then you click add. Oops, sorry. The D1, by the way, is the distance from the start node. So, if this is 4 meters, midway to that is 2. Okay? So, 2. Then you click add. Then close. Oops. Ito yung una nating ginawa. So, I will just delete that. Then, ito. Mapapansin mo, pag dinouble click mo yan, meron siyang 2 dito. Then, global Y. Now, I will assign here. Okay? After that, punta tayo ngayon sa utilities and then click mo si command file. Just save. Save mo lang yan. Ang gagamitin nating analysis is plain only. Okay? Plain. Kasi XY lang naman tayo eh. Pag space yan, XYZ. Okay? Maghahanap siya ng third coordinate. And then, ito yung joint coordinates, yung 00, 06, something like that. And you will notice na ito yung node number, tapos ito yung coordinates na XYZ. Mapapansin nyo na yung fourth number, 0 lahat yan. Okay? They are separated by colon. And yung first number niya, yan yung node numbers. Okay? Tapos member incidence, ito yung element 1, element 2, element 3, element 4, element 5, element 6. And then yung 1 and 2, yan yung start node, end node. And then 2, 5. Now, let's compare that with our spreadsheet. Okay? Yung coordinates mo, eto yon. Okay? Take note, 1, 0, 0. Then 2, 0, 6. And then 3, 4, 0. Ayan yon. Tapos, tong member incidences, eto yon. Okay? So, 1, 1, 2. Then, next is 2, 2, 5. Ayan. Then, next is 3, 4, 5. So forth and so on. And then, ang ating material is isotropic steel, or this is the elasticity. Sa ating sample, the elasticity is 210. Lahat yan. And, dito, gawin na lang natin siyang 2.1. Okay? So that is the same as 210 by 10 to the 6. Okay? Next is etong G value. Wag na natin galawin yan. Total, dinisregard naman natin dito kay spreadsheet natin. Okay? And then, ito yung member properties. So, yung AX, yan yung cross-sectional area. Ito. Tapos, IY, IZ, yan yung moment of inertia. Okay, next, we have materials, steel members 2 to 6. Ibig sabihin, ang elasticity niyan ay 210. Okay, tapos, ito yung first node is pinned, and then nodes 3 and 6 are fixed, and then ito yung loads. Ano yung loads na yan? Ito. Okay? So meron tayong 40 kilonewton meter, ito, global X, tapos 50 kilonewton meter negative, global Y, and then you have the concentrated load 200 at distance 2 meter from the start node. And then dito, sa constants, material, steel, gawin mo lang yan na all. Okay? Then, finally, dun sa dulo, just before finish, mag-type ka dyan ng perform analysis. Tapos, load list all. Okay? And then you save. Close. Dapat walang error na lalabas, and then you click analysis and design, and then run analysis. Okay, before going to the output file, papakita ko lang ito. So yung processing joint coordinates, ibig sabihin binasa niya ito, tapos member information, binasa niya yung ating mga properties. Ayan. Tapos, support conditions. In-analyze niya yung displacements. Ito. Siyempre, kapag walang displacement, for example, ito. Blanco lahat yan. And that is node 3. Tapos node 6. And what are nodes 3 and 6? Ayan. So kapag displacement, ibig sabihin, fixed support siya. Ayan. Okay? Next is processing support condition, and then load cases, processing load vector, and then eto, yun. See? processing element stiffness matrix. Yan yung mga pinaggagawa natin na element stiffness matrix. So, gumagawa din pala si software. After that, kinalculate niya yung member forces by gumawa siya ng global. Tapos, nag-inverse din siya. So, things like those. After that, nag-multiply siya ng inverse tsaka yung force matrix para ma-determine niya yung displacement. O, yan. See? Naka-create siya ngayon ng displacement file. Yung analysis successfully completed, ang ibig sabihin yan, yung matrices mo is correct. Ano? Ibig sabihin nun, wala siyang error, tapos square matrix siya. Okay, after na-compute niya yung mga displacement, sinolve niya yung mga M1, M2, ito yung section forces. Okay? Tapos gumawa siya ng file para meron kang output. Okay, so 0 errors, 0 warnings, 0 notes, things like that. Now let's see the output file. So, click mo yan and then click done. X ko lang yan. Now, let's check the moments. So, view, punta tayo dito. Click mo yung view model from positive Z, or this is simply front view. No? And then, punta tayo ngayon sa post-processing. You just click OK. Palakihin natin ito. Tapos, i-click mo yung naka-click yung displacements, ano? Click mo ulit yan. Kapag click, merong shadow dun. So, I will press Control and then, while pressing Control, hold on it, you scroll. Yan. So, yan ngayon yung displacement nung building habang niro-roll mo yung scroll and pressing your Control button. Yan yung displacements due to the loads. Now, let's check the moment. So, I will turn off the displacement and I will click on MZ. Yan. See? Now, let's look at the moment diagram. So, I will press Control, press and hold Control, and then scroll up, scroll down para mag-magnify yung moment mo. Yan. So, meron din siyang displacement. Yan. Enough ko yung displacement. Next, paano natin malalaman yung values? So, punta tayo ngayon. Punta tayo ngayon dito sa results. Click mo yung results. Okay. Tapos, click annotate. Ayan. Then, you click beam results dito. Then, dun sa bending, you click ends, tsaka midpoint. Okay? Then, you click annotate. Yan. Then, close. Ngayon, maximize natin to. Yan. So, let's compare it with our output. Yan. Remember na yung output natin kanina is ito. Okay? So, this is 53.81. Pagdating kay stud, 54.19. And then, here, 212.01. Dito naman, 210.9. Tapos, dito, sa atin, 174. Kay stud, 176. And then, dito kay node 3, 11.55. Dito kay stud, 13. Sa node 6, 203. Dito sa stud, 201. And then at node 7, 210. Dito kay stud, 210.47. Okay, so hindi malayo ang kanilang difference. So that's how to check your work, or that's how to compare your work with stud. Now, let's go back to our spreadsheet or dun sa ating stiffness matrix method na mano-mano. What if papalitan natin tong shear deformations to no? Malaki kaya ang difference ng kanyang moments? Yan, see? So, yung difference ng moment niya, malaki. Yung sa element 2 from 53.81 naging 46. Ang layo ng difference. Yung 212 naging 215. Tapos, yung sa element 5, yung 210 naging 198. Okay, so, that means na pwede mong ignore ang shear deformation or maglalagay ka ng vertical displacements. Pwede rin yun. Okay guys, so that's it. Pinakita ko lang na you can compare your output with that of software. So thank you guys for listening.